Let's look at an example problem related to this. Say we had a piece of steel, rebar, and it weighed 360 grams. We drop that into 425 milliliters of water that starts out at 24 degrees C. The final temperature of the water was 42.7 degrees C, and what we want to know is the initial temperature of the piece of rebar. So as we often do, let's draw a picture. We know that the water is 425 milliliters in volume. Let's go ahead and assume that that's going to correspond to 425 grams of H2O, since we're going to need to use that mass in combination with the specific heat. We also know that the water starts out at 24 degrees C, 24.0, and goes to 42.7 degrees C. In terms of the steel, we've got a mass, 360 grams. We've got some initial temperature, which we don't know. That's what we're trying to find. But we know the final temperature, 42.7. This is the temperature at which thermal equilibration has been achieved. And so the final temperature of the steel is also 42.7 degrees C. Now, a few things about this. Intuitively, the steel started out hotter than this equilibrium temperature. So our final value should be greater than 42.7 degrees C. If it's not, we've got a problem. Additionally, let's write out the heat balance here. Let's think about the directions of heat flows. Well, the steel bar started out hotter than the water, so heat is going to flow out of the steel and into the water, and we can write a heat balance equation recognizing that the signs of those heat flows are going to be equal and opposite. There's the first law coming into play. We're assuming no heat flows beyond the bounds of this outer blue box. So the heat released by the steel is going to be equal and opposite in sign to the heat absorbed by the water. And now we can take each heat term and expand it based on the information we have. So for example, we have the specific heat of the piece of steel, 0.449 joules per gram degrees C. So let's expand this left-hand side in terms of the specific heat of the steel. The mass of the steel times the specific heat of the steel times the temperature change for the steel is going to show up on the left-hand side. And on the right-hand side, we've got the mass of water. We've got its overall temperature change, and we know the specific heat of water. So we can go ahead and write that out. The mass of water, that's the 425 grams. Specific heat of water, we can always look up, that's 4.184, and joules per gram, degrees Celsius. And the delta T of the water comes from these measured values. So I'm going to write out the numbers really quickly and quickly calculate the result, and we'll take a look at where the initial temperature shows up and isolate that barrier. All right, so our only unknown in this equation now is the initial temperature of the steel. The way I like to solve these problems is to multiply everything out, collect terms, and then just solve the kind of algebra problem that pops out of that. After rearranging things, we end up with this ratio plus the final temperature of the steel, 42.7 degrees C. And when we calculate all this out, and I'll let you verify this on your own, the final result that we get is 248 degrees Celsius. So a little bit algebraically involved, but conceptually the key is this heat balance and then the expansion of the heat of each term in the heat balance in terms of quantities that you know from what's given in the problem.